Hi, this is week 5, and today we're gonna talk about neural networks. This one says Perceptron algorithm. So Perceptron is the very easiest form of neural network. Actually, it can be considered also as logistic regression. So as you learned before, so actually most of neural networks are many logistic regressions that are combined together. So the prediction problem, this is type of classical machine learning problem where you are given x, so you're given some data, some features, and you should predict y. So for example, like in images, you are given pixels and you should predict y. For example, in text, you are given words and sequence of characters, as you can say, and you should predict something. For example, it's is it positive or negative or something like this. Given x a book review, predict y. So for example, we have book is positive or not about book, and with English or Japanese. Sorry, is it English or Japanese? What does it mean? A sentence, I read a book and then use try to predict a syntactic parse. So for example, is it noun, is it verb? So it's actually is also important part. Introductory of a sentence for Wikipedia, predict whether the article is about person. So for example, what is about, who is about this text, or about this one, it's about person or not person. So this one is about historical site. So you can also use some machine learning problems. So for example, we have this text as before. Ganzo was Sanron sect priest in the late Nara and early Heian periods, and Shikuzan Shogatika Fudumoyo is a historical site located at Magura, Maizuru City, Kyoto Prefecture. So how do we predict it? Actually, it is like easy because if you have word priest, sect priest, and for example this is historical site, like you understand that this you can look at these words and understand that they are like quite importantly they describe the text. So it seems here. So for example, priest is about person most probably, and for example Kyoto Prefecture not person. Site is also not about person, and so this one is mostly about people because cities are mostly not have these periods of time. So we can combine these features. This we can say as a feature. So it was a text and we convert text into some features like before in logistic regression, and say here the word contains priest, not word but document. Sorry, this is weight. So we can say that each document have some value contains priest, so it will be 1 or 0. So if it contains, it will be 1. If it doesn't contain, it will be 0, and etc. Same here. Each feature has a weight. Positive it indicates yes, and negative it indicates no. So here you see that it's 2, -3. So you can there is some weights which are like prepared before for you, and you can use it. For an example, some the weights. So for example, you can say here we have a new example. It is a very special example because it contains many features from two documents, and it's like mix of that. It contains some year, and it contains some priest, profession, and Kyoto Prefecture. So here you multiply these ones. So for example, it contains this one, so it will be 1. You multiply by 1, this is 1. So this goes here. Also, Kyoto Prefecture contains 1, so it is equal to 1. We multiply by minus 1, and it will be minus 1. So actually, if it is, the values for things that are positive and negative, let me say that in math, sine. So actually, the formula, we can say that sine multiplied by weight multiplied by feature. So if it contains feature or not, and it is like it is in that vector form. So this v is some vector. This is also vector. This is vector of features. So you multiply and you got the number. So if you not use vector notation, you can do it like this. So it's actually multiplication of this vector to this vector. You can represent it as a sum. Sine is okay. So sine means that if you have here minus 5 value, it will show minus 1. If it will be 5, it will be 1. So it only sets only 5 if it is plus 1, if it is yes, and minus 1. So this is feature, unigram features. You can use unigram features. So for example, a site located in Maizuru, Kyoto, the temple, etc. You can combine them and calculate to think. Sorry. So for example, you have a site is located in Maizuru, you have text, so you can do it. You will have this features. So for example, here comma is 2 times, you can set it as 2, and then you multiply it by weight. These weights are like they are not predicted. They are. So for example, I should assume that they are given, and you will multiply it, and you will get the sum. Pseudocode for prediction. So this is the pseudocode. You can see it as you can see for each x in input file. So you take x and make from them features. It will be phi, and then this function is predict1. So you give it w and phi, and it will show the sum result. So this is very abstract representation of how this neural network works. Pseudocode for predicting a single example. So this is predict1. You give this one phi w word, and then if name exists in w, score value in name, and then you get this. You got this. If score is more than 0, then you have. For feature creation, predict1 was. This one is calculating the sum of these values, and this one is create features. So create features that you take each word, and in array phi you so for example you make this one. No, so you add 1 if you find this word, and you modify its value. Learning weights, manually creating weights is hard. Many possible is features. So actually, as you saw before here, this was some values. All of these values, so they are given. But now let's understand how, if they are not given, how we work with them. Manual creating weights is hard. Many possible use of features. Changing weights changes results in expected weights. So for example, you can create some features. You can write it by yourself. You can try it, or you can try to predict them. So you can try to find them which are most optimal for this kind of task. So we can learn from labeled data. So for example, you have already labeled data. So this is the text. For example, Fujiwara no Shikamori was a samurai and poet who lived at the end of Heian period. mod, so it is y if it is about people, -1 if it is about city. And now online learning, so this is called learning process when you learn data. So here you see update weights. What does it mean? You in the beginning you try to randomly set some weights, and then you set up some weights, create map W. So we can, for example, do it randomly or put it 0 or put it 1 or something like this. And then while you learn, so you give iterations, you give all of this data to your computer. And for each label pair x, y in the data, you create features, predict one. So you predict the value, you try to predict by these things, by these features. You can transfer them into features, and then you try to predict with this W. This W now is not like optimal, some random numbers you can guess or 0 numbers, and then you do something like this. Predict one, WPHI, you try to predict. It most probably will show something bad, something it will show mostly not correct results. It will show also correct results maybe, but it will be not most of results will be not correct. So what you do, you say if y predicted is not equal to y, then update weights. Try to classify each training example. Every time we make mistake, update the weights. Many different online learning algorithms. The most simple is the Perceptron. So in this case, we update the weights and try to make it. So we update. So we had some W. For example, it was vector of like 1, 0.2, 3, 2. So this was weights. And now you, after this step, you have new numbers. 1.5. 0.2, 2 and 2, for example. So for example, in this case we have first converted and third number was updated. So this is called update weights. So you change the weights, and they change. If y1 increase the weights for features in fx, features for 4 positive examples get higher weight, decrease the weights for features for negative examples get lower weight. So it is like very simple algorithm for updating weights. It's not used in real cases, but you can understand. So for example, you are given vector weights and features and y. And y is here is actual value, like it was, for example, this one 1, but learning predicted it as 0. So for example, this was 0. So y. Okay. So you are given weight and phi. So it was 1, but it predicted 0. And you try to change. For example, you say if value for each value of weight, you take value and multiply it by y. So for example, the positive values should be better and bigger, and the others should. If it must be positive value, then its weight must be bigger, and if it must be negative, so its number must be smaller. So for example, this is located as initial update. All W's are 0. So you send a new text here. Y is actually -1, and you multiply it, and you got this 1 result. So these two things are not equal. It hasn't predicted, and then you add this one. you change the weights. So now weights are this one. So weight is equal to weight plus y given px. So in second update you also take this one, so it must be 1, but it outputted -1, and now in this case you make it as this one, so in this case weights will be less for -1, and so this is called weight update. Okay, this was part 1.